Alright, so what we're going to do now is, being that we have our Powerflex stuff in here, we have basically our controls in here for this starts, stops, and stuff like that. So, we're controlling our Powerflex on and off. We're controlling our speeds. We're doing everything we're supposed to. We put our stuff down here to migrate and understand what is in reference to the speed. What we want to do in our Powerflex 525 now is add some, basically some fault code. So let's go ahead and add another row, and let's go ahead and let's make this real simple. Let's just come in here and we'll call this Powerflex. Actually, what do we call it? We'll call it fault status PF 525. And again, we're going to alias this, right? Because this is, and don't we're gonna actually show some different stuff here. So we're going to get down to, so we actually have this as a fault status. Now this is the faulted status, right? So now one thing we can do is we can say, okay, we're faulted. All right, so we understand we need to use this bit up here and say, okay, well, we can't run anymore, right? So we're faulted. We don't want to be able to start if we're faulted. But in that instance too, you can't necessarily start when you're faulted anyway, but you do want to limit that. You want to limit the ability. So let's come up here and throw that in there and throw this in here, and just make sure, for the sake of control wise, what you're doing is you want to make sure you throw in another command to verify that the stop has happened. And the reason I say this is because when a drive logic is going through the process, right, it sometimes will latch itself into a run or to a in a state where it's running, or it tries to run and it never does run. So then, and you try to start it again, it never does actually run because it's still stuck in that last state. So the best way to do this is to always default back to a stop on a negative outcome, right? Which would basically be a fault, right? Okay, so when this fault happens, what we're going to do is we're going to say, we're going to give the ability to actually have a fault reset. Now, with this fault, and the fault happens, and the fault has actually, let's actually come in here, and what we used for our HMI before. Let's see, what did we use for our HMI reset? Come in here and we used this bit right here for, we used our HMI reset right here. Let's grab this bit, let's come over here and let's go here, and what we'll do is add our speed control, right? So I mean, not speed control, but our fault. And what we're going to do is add that bit in here, and so we'll tie that in. And this is, again, this the HMI reset we already have, right? So all we're saying is that it is faulted, and then that way we want to give it the ability to have a reset. So, and what we're going to do too, and we're going to actually tie this into our ALMD, and we're going to come in and actually give it a ALMD as well, because we added our alarm system last time. And if you haven't seen that video, you can check that video out. But so we're going to call this, we'll call this alarm reset, our fault reset PF 525. And we'll come in here and we'll do this. We'll do the alias again. And again, out of all my years of programming, I mean, aliasing is just the best and simplest and the best way to do this. Like, clear all faults clear all faults is what we should use. So that's we'll populate in there. Now we can't actually indicate and make this happen, but unless we were actually do something to make it obviously fault out. But we can actually add like controls in here. Like in a normal situation, what you would do is, if the drive didn't do what it was supposed to do in a set amount of time, it would be a stall fault, for instance. but let's go ahead and add our ALMD in here first. So let's copy this bit, and let's go back into our ALMD program. So our fault program. So in our faults, remember we just added a couple faults, right? Now, well, let's add another one. Let's come in here and we'll call this. Now we're going to add in this one. All right. So this is the exact reason why aliases are beautiful, because you can tie this in and use it just about anywhere. And now it's used in the second one. So what we're going to do is we're going to come into the second one, right? So we're going to go into ALMDs, and then we're going to add another one. And what we did is we called that. This was the second one. Let's copy this, and let's go back in our ALMDs, paste that in here, and actually change that to an actual, actually wrong, examine open. And then what we'll do, just to make this simple, is we'll copy this one and we'll paste it, because we've already done this once, right? We'll name this fault 2, and then again, so we're going to come in here and durations and stuff like that. Well, again, we'll come in here and edit this. Well, we got to make it a tag first. I'm sorry. So then we'll edit it. And again, what are we going to do? So we said, okay, anything critical is going to be 1,000 severity, right? So it's going to be really, really severe. Now, again, so coming into it, we had our fault string, right? So fault string is 0. This is going to be the next one's going to be 1, I believe. So let's actually add that in there. Let's come in here. Let's add this in here. Let's take that back. Let's select the right one. Come in here. This would be that one. And then we want to come in here and add our string. This would be our string value. Add that in. Come over here. Now that's tied in together. Have that there. And if we get a fault, we're going to come in, but we need to actually populate that name. So it's important to remember, go back in our tags, to throw that in there, and then come back, and then that way you can select it. And we're going to go back into faults, system faults, and then that's where it's going to populate. Then we're going to go down to descriptions, text, and then we're going to go here, and then we're going to populate that here. Now this is going to actually say this is going to be our Powerflex 525 fault. So that's what we're going to get. That's going to be the string text when we get on our HMI system, if it were to actually fault out, right? So if we come over here to our fault system, and we clear all of our faults we currently have had in the past. Actually, let's come over here. I think it's a not acknowledge. Yeah, so we clear all our faults, and then if we get a fault in, what we'll do is it will actually come in here and do that. We can add filters too, but we have no filters yet. But so just coming back and talking about that, we haven't done that from our last video, but when we come down to it, this is just adding another fault in there, right? So we want to make sure when we add a component, like we're adding this component, we're actually adding it in as a fault, so that the whole system can be acknowledged, and the operators and whomever is operating the HMI can actually see that as well too, right? So think about that when you're doing that. Now, if we get into the next thing and we say, okay, well, what is another fault that could happen, right? So, all right, so that's a good question, right? So we could say, okay, well, another fault would be something like the deviation. Like, say for instance, if a natural situation where a drive is under a load and it's not going to accelerate as quickly as it probably should, right? Because it's going to actually it's going to recognize where it's at as far as this feedback. Now this is where you need to use your feedback and not your commands. So this is where you would use your frequency, not your frequency out, but your feedback. Now again, so we're going to use our command, okay? And then you have to understand that your frequency and your command can be compared against each other, right? So what you need to do is come in here and create some logic around that. Now, first and foremost, what we can do is we can say, okay, well, the motor is running, so it's active, and we need to actually, to be better off with that, we need to have a bit that says active. So we need to actually delete that. Let's come in here. Let's add a bit. Let's add a bit right here, and let's call this Powerflex. Actually, let's call this active. And if I could spell that right, that'd be fun. So anyway, that's what happens when you do videos late night. And we'll call it Powerflex 525, and then we'll come down here and alias it to the actual trainer active bit, right? That's again where we get this active bit. Okay, so then we can actually use this bit up here to coincide with this logic up here, just like we did, because that's the one thing we did not do, is we didn't alias it here. So I wanted to fix that while we were here too as well, because again, we're building upon stuff that we're doing, right? So okay, so now we're gonna go in here and we'll just simply do like a math, and we'll multiply. And before I forget too, another cool feature that you can do, and I want to show you this, and this is recently, right? So this is actually coming up. Even version 30 and below doesn't have this, so because again, when it comes down to it, this is obviously connected to more or less connected components, the way things are. You know, as far as like the new UI of version 31 and 32. The cool thing is behind this, right, is you come down here to help. See how it automatically synchronizes? This is live, so you can actually see all the information on it, but that's not the cool side of what I'm actually bringing up, right? And you can see all the information. The cool side is you can come to help. See this help file down here? And you can get software help, right? You get software help that's pulled up right here. This is another cool thing. You can get Powerflex 525 help. You see that? That's a really cool feature, right? So you have problems with you get your manuals right here. You can look at your manual, pull up your manual just like that. Just that easy. Of course, I already had one pulled up, but I mean, you get all this stuff in here that you can actually use, and I just wanted to highlight that and bring that up, because all it is bringing this up, and all you have to do is literally double click on this. If you have all of your stuff drive matched like I showed you in the last couple of videos, then it's just a matter of using this tool down here, right? So again, all right, so now that we're doing this, right, so we're doing a multiply. So what are we going to multiply against, right? We need to get our speed command, and then let's just do like a deviation. Let's call it dev, and then we'll just call this, we'll make it a real so that we can get a decimal point, and then we'll call this like, I don't know, 0.5, actually 0.5, yep, and that looks good. And then down here we'll call this down, you know, we'll basically call this the deviation limit, or the tolerance, if you would. So what you want to do is you want to call that the tolerance of what's going on. So you want to say this is going to be the dev check, if you would. So the dev check, and we'll again use that as a real, because that's going to be the basic premise of what we're doing. You can come in here and you can do some adds, and we want to add and then subtract to kind of get what I like to do too. And this is just me, but I like to kind of come in here and stack these on top of each other. This is just me, because I like to have both of these kind of viewpoints. And again, so using this dev check, right, so then you would come in here and you would use this against this. So we would come in here and we would use the actual speed command again, and then the speed command again right here, And what you're trying to do is you're trying to create the deviation, and you're doing the deviation check and actually creating that tolerance right there. So this is going to be like a high, and this is going to be a low, right? So this would be the Powerflex 525 dev high, right? So the deviation high, right? And then you would come in here, and again, this would be a real, and then this down here will basically mimic, right? So you basically mimic, and you're going to create that as a low. And then what we'll do is we'll just come up here, make a new tag, change that to a real, get that in there just like that. And as we're doing that, what we're going to do is basically come in, and what we're going to do is add some more logic to say that basically, you know, let's just do that. Let's just add this real quick. And the point behind what we're doing is trying to see if there's a deviation. And this is, think about this. This is a loaded system, and it's not a system that you would generally have a feedback on, like an encoder or something like that. But it is a system that you would actually, you know, kind of still want to monitor to see if there's like a stall or something. So this is again where you would use this. So if you come in here and use some compares now, we would do greater, and then we would obviously do less than, and then you can also, I don't know, you could argue the fact that you could use a greater a limiter or something like that, but it's almost better to do it this way. And then what we would do is we would grab our Powerflex right here. So as you know, I'd like to still keep this as let's just actually come in here and call this the actual Powerflex output, right? So they'll call this output PF 525. And then we'll grab this, alias it, and then come down here and do trainer, add the trainer in there, and pick the output. This is going to be, I think this is going to be the output frequency, which is down here, because this is what you're reading back, okay, from your drive. And you want to make sure that this is obviously the greater and this is the lower. And then what you want to do is have a timer in here. You can have like a TON or something like that, and we'll call this Xstall timer. Call this stall PF 525 time. And that's just to kind of give it a breakpoint, or just kind of give it an indication. Now, generally speaking, you want to keep this moderate. Depending upon the load, you can keep it right around 5 seconds. Like I say, it really revolves around that. And then keep this at the branch level. Change the branch level right here. And then what you can do is you can use this down here to say, okay, this is done. This is done. What we'll do is add that there, and then basically paste this down here and say stall fault. Then we'll say PF 525, and then we'll keep that there. Okay, so now this needs to be where you can understand kind of what's going on. Is you obviously still want to have this as a stop factor. So with this being said, right, well, just to show you real quick, we can start it, and we're gonna turn the speed down a little bit. Then we'll come over here, look at the logic, and you can see it didn't take that long because of the simple fact that I don't have a motor attached to it. But if I hook a motor attached to it, it's going to change, right? So you see I'm actually changing the speed. it's the deviation check, right? And it's just checking the deviation on that, right? So all we're doing is basically saying, okay, well, the motor's doing what it's supposed to. So at any given time it stalls out past 5 seconds, we want to fault out. Okay, so with that understanding, okay, we'll stop the system. With that understanding, what we want to do and see, we're still monitoring on the active, so it still will monitor the active during a slowdown, during a ramp down, right? So if it is faulted, if it does stall, then we want to stop. Now it doesn't necessarily constitute a fault reset, but again, when it comes down to it, we still want to monitor that. So let's come over here and say, right here, we want to stop. Now, this is going to be a stop. This is going to come over here just like that. And we're going to stop the drive because we're not holding the drive, right? So we're not holding the drive on, we're just one-shotting, because on a Poweflex 525 you don't need to hold the on, you just need to give it a one-shot, right? You just need a one-shot on or one-shot off, right? So one shot to run, to latch that one shot in, because the drive logic is so fast, it latches the run in, and then it basically, and that's the thing that a lot of people don't understand about the Poweflex series of drives, is you're latching in the logic will catch that run. That's exactly why I'm talking about when you're failing safe. When you're failing to start, you definitely need to issue a stop command all the time. Okay, so even on a fail start, right? So you would definitely come in and issue the stop, because you want to get that drive back into a happy state where it knows if you hit a start command again, it will start. But being that we have this said, we need to come down here and add this as an actual alarm. So we're going to come in here, add this into our alarm system. Okay, paste that. Actually, let's come in here and add that just like we did. Okay, so now this is number 3. Okay, so that's good. So we have a stall fault for Poweflex, and you can name these whatever you want, right? But let's just copy this and let's go back over here to our ALMD. Let's add this, and we're going to add this in there just like we did, very simply. And normally, like I say, normally you would have all these pre-built out, but we just haven't yet, because, well, we just hadn't had that time. We were kind of building some stuff out and building all the stuff out for training and stuff we've been doing, so we haven't had time yet. Now, again, so this was the system faults. And then we're grabbing, this would be our description text, and our description text is 2 on this one. So we're going to come in here and add our description text, which is tag, add that in there. So we're giving our message to monitor that tag, and then we want to come over here. Now we want to populate this data too, so remember that. Okay, so we're coming back into faults. Now we want to come over here and populate this data. We're going to say Poweflex 525 motor stall fault, because we're issuing a stop, right? So we definitely want to issue this command, or issue this text, to our HMI system and our faults in our alarm system, and make sure that the system knows that it actually did that. Now, with these 2 faults, right, what did we fail to do? We didn't put neither one of these into the state machine. So we're going to come into a state machine, right? We're going to come into our main controls. Actually, it's not main controls, it's the state. And we're going to come to our state machine, and this is going to actually pop in this not ready. And the not ready would be, let's do this, come in here and add the new rungs, because anytime we add something in, we're saying, hey, if it faults out, we definitely want to know about it. So let's go back here, and we're going to grab this fault, and we're going to go back to our state machine, and we're going to grab this fault, and that way if it faults out, it will shut the whole machine down. Because now if we're adding in another drive component, or just like we talked about before, we want to stop the system. We want to fault out the system. We want to stop the actual state machine. It's a finite state machine, so we want to stop it all together. Now again, we don't have Powerflex happy or anything like that like we did the other ones, but we've added some controls to it too, right? So we've added some simple Powerflex controls. Come in here doing the start stop. Come in here adding some stuff. We've talked about, you know, some cool things we can actually come down here and look at as far as the natural components that are there on version 31 and 32 and above. So think about that, right? So think about all these helpful tools that you have now to better aid you in troubleshooting and aid you in things you're doing. And again, I'm only running 5.1 for my firmware on this Powerflex drive. I could be running 6.1 right now. 6.1 is out, so I may flash this thing up. But again, I wanted to make a good solid video and give you some interpretation on basic implementation of this. Now I'm going to actually scrap all this logic probably, and then come back and add some I'm going to add some plant packs to this, and then show you how to do the plant packs and add that to our HMI system that we currently have. That way we can actually get a little bit better and do some more functional stuff on top of what we've already done. So we're building this stuff out, we're getting stuff better, and we're growing and we're getting better. So I just wanted to implement things and show you how we're doing this on this trainer. And again, more verse environment of version 32 and more fluent as far as, you know, getting components done. So hopefully you enjoyed this process and you enjoyed this logic, enjoyed, you know, learning and growing so far. And again, there's 1,000,001 ways you can control something, but understanding the way you do it is proper, right? The foundational elements, understanding the drive logic in, you don't have to hold it, right? You just give it one shot, it's on, it's off. Simple as that. You fail off, simple as that. If you fail off, you can always start. Simple as that. This is that's standard protocol on anything from drives to actual servos to anything. Any drive train should be, that's your standard protocol. You should fail off and always make sure you unlatch that start command, because the drive has an internal logic, and I'll show you that too. The drive has an internal logic. So if we go to our trainer, the drive has an internal logic that is just like anything else, right? It has a drive word, right? This drive word is actually telling you what is actually doing, instead of actually using the actual commands for the start, stop, and stuff like this. This command word, you can actually look at the command word and see exactly what's going on, right? So you have a status word, and then you have a command word. You can use the command word instead of stop, start, jog, clear, and all this. You could use the command bits. All these command bits could be aliased to actually use that, and there often are aliased to use that. So we may end up coming back and showing that as well. But the point of this is you should always, on a drive system, you should always fail where you cut your drive logic off. That resets the actual drive or controller that you're using to a state where you can always cut it back on as soon as you get the problem fixed. So with all that said, hope you enjoyed this video, and we'll see you guys on the next one.